Good morning to all. Am I audible? Ajay?
Yes, sir.
Okay. Krishna? Krishna, am I audible? Krishna Mali?
Yes, sir, audible.
Okay, okay. So, during last lecture, we have started this second chapter from the first syllabus, first section, that is velocity and acceleration in mechanism. So, this we have seen in significance of velocity acceleration in the mechanism. Then two methods, relative velocity and relative acceleration, and cleans construction. So preamble, that is fundamental concepts: linear displacement, angular displacement, linear velocity, angular velocity, speed and velocity, then linear acceleration and angular acceleration. So this we have seen: linear displacement and angular displacement. So these two definitions we have seen. Then linear velocity and angular velocity. So then we have now next you can write linear acceleration and angular acceleration. So please write in your notebook. So what is linear acceleration? It is denoted by alpha. It is rate of change of linear velocity with respect to time. So it is vector quantity, because in linear acceleration is nothing but change of linear velocity, and that linear velocity is vector quantity, and that rate of change of linear velocity with respect to time is nothing but the linear acceleration. So therefore it is also vector quantity. Unit for this is meter per second square. So please write down this linear acceleration. Then next term, that is angular acceleration. Angular acceleration. Angular acceleration. So inside the bracket you can write alpha what is this angular acceleration? It is rate of change of angular velocity with respect to the time. So as angular velocity is a vector quantity, this is also vector quantity. So write down this. Write down this. Up to this completed? Ajay, up to this completed?
No, sir.
Please write down. Then one more slide with respect to this these basics. Okay. Up to this completed? Prem Savan, up to this completed. One more slide is remaining for preamble regarding fundamental concept. Ajay, up to this completed, have you written? Revannath,
Yes, sir.
Krishnamani.
Yes, sir,
Yes,
completed.
sir.
Okay. Then write down vector and scalar. So this is last slide with respect to the fundamental concept. So what is vector? So vector in physics is a quantity that has both magnitude and the direction. Though it is simple, but you should write down. And how it is presented? How it is represented? So it is represented by an arrow whose direction is the same as that of the quantity. So velocity and acceleration. So we need to represent direction also, and for that these small definitions are required. So it is typically represented by an arrow whose direction is the same as that of the quantity, and its length is proportional to the magnitude of that quantity or quantity's magnitude. Then next one, that is scalar. So it is a physical quantity that is completely described by its magnitude. By its magnitude. So some of the examples of scalar and vectors are given in two rows given at the bottom sides. So scalar quantities: time, distance, mass, area, density, work, temperature, speed, energy, and power. Whereas vector quantities: lift, displacement, weight, drag, then force, momentum, acceleration, and velocity. So I request all the students, they should take all the content, they should write all the content on this slide. Okay, completed. Swapnil, completed. Krishna, completed.
Wait a minute, sir.
Okay, okay. Then next, now this is useful with respect to our graphical method. So with the help of graphical method, we are going to solve numericals of velocity and the acceleration for different mechanisms. So write down relative velocities of two bodies, relative velocities of two bodies, two bodies moving in a straight line, moving in a straight line, moving in a straight line. Okay. So first I will explain, then you are going to write in your notebook. Now whatever dictation or hereafter whatever content on the slide, that is important with respect to this unit, and use also useful for writing answers with respect to the MCQs. Okay. Now here, to determine relative velocities of the bodies moving in the straight line. So for that, we are going to consider two bodies moving along parallel lines as shown in the figure A. So this is figure A, this is body A, this one is B, moving in this direction. So this VA is nothing but the absolute velocity, that is the body A moving in this direction, with which body A is moving in this direction, and this B is nothing but VB is nothing but absolute velocity of body B with which it is moving in this direction. So this VA and VB are absolute velocities, and what you are observing from this diagram, that VA is greater than VB. VA is greater than VB. So we have seen velocity is vector quantity. As VA is greater than VB, that means magnitude of velocity of body A is more as compared to the magnitude of velocity of body B. So that's why we have shown its length as per the magnitude of this VA, and VB as per the magnitude of this B, velocity of B. And for that we have considered here VA greater than VB. Now relative velocity means, what is velocity of A, relative velocity of A with respect to B, or relative velocity of B with respect to A. म्हणजे A ची velocity कितीनी जास्त आहे रिलेटिव्ह टू द B, म्हणजे A in comparison with B or B in comparison with A. So relative velocity of A with respect to B. So how to determine this? So we are writing here VAB. VAB. So please see carefully. Our aim is to determine relative velocity of A with respect to B, of this A with respect to B. So first alphabet we have taken, that is for A, and this is the second alphabet that we have taken. So VAB, we can say that relative velocity of A with respect to B, relative velocity of A with respect to B. So it is vector difference of VA and VB. So how to take the vector difference? So this is VA, this magnitude is more, minus this VP, and that difference is nothing but VAB, or the relative velocity of A with respect to B. It is nothing but difference of VA and VB, and that is equal to VA, vector VA minus vector VB. So this is nothing but relative velocity of A with respect to B. आता ह्याच्यात दुसरी केस कशी असू शकते? VBA, relative velocity of B with respect to A. Again we are going to take the difference. So please take down this diagram and write here figure A, figure A. Then this you can write hello. Please write. Then write this. For this you can write V A B is equal to directly VA minus VB. Okay, up to this completed. Krishna, up to this completed.
Yes, sir.
Samadhan, up to this completed. Samadhan More.
हाँ सर.
Okay. Then draw this figure B. Draw this figure B. So just listen instructions. Draw this figure B. Draw this figure B. So first draw this OA vector, then show this VA that will indicate magnitude of velocity of body A. Then here you can show B and show this much distance which represent magnitude of velocity of body B. Body B. Okay. Okay. Up to this completed. Simple figures. Up to this completed.
No, sir.
Please take it down. Hello, Onkar.
Yes, sir. Completed.
Okay. So, whatever dictation I am insisting to take in your notebook, so that is the importance. So, I request all the students, because examination may be MCQ type, and if such diagram is given, then this will be option for answer, right? So, for figure shown in, as shown in the figure, body A, body B, which condition is applicable? So such type of question may be asked for MCQ. Okay. Now from this from this figure, the relative velocity of A with respect to B, that is VAB. So in the last slide, so we have written here directly this VA minus VB. But now with this figure, so from figure B, the relative velocity of A with respect to B, that is VAB. आता त्याच्याऐवजी जर असं असतं, द रिलेटिव्ह व्हॅलॉसिटी ऑफ बी विथ रिस्पेक्ट टू ए, तर इथं काय झालं असतं VBA. आता इथं काय VAB, म्हणजे रिलेटिव्ह व्हॅलॉसिटी ऑफ ए विथ रिस्पेक्ट टू बी. With respect to B means that is second body, and first we are denoting as a first alphabet here, and it can be written by taking the vector difference. Here this VA, that is absolute velocity of body A, how it is shown? OA. How it is shown? OA. This complete length indicates the velocity of body A. And what is second? Velocity of body B is VB. I am not saying that relative, only velocity, absolute velocities. So that is indicated by this OB. Now, how we can write? Just by taking the vector difference. So VAB is equal to vector VA minus vector VB. This is equation 1. So VA, this we have written here, and VB, this we have written here. Right? Now, the same equation 1 can be written in terms of vectors like this. इथं लक्ष द्या नीट. Vector BA is equal to vector OA minus vector OB. Sorry. So we will show here this on this side, and this is only for this. Okay, and this is OA. So vector BA is equal to vector OA minus vector OB. Now here what we are observing, this is A. So vector BA means relative velocity of A with respect to B. तर इथं पहिल्यांदा B घेतलंय आणि इथं लिहिताना कसं लिहितोय आपण VAB आणि त्याचंच वेक्टर फॉर्म मध्ये कसं लिहितोय असं लिहितोय, राईट. सो फॉर अनदर वे, फॉर relative velocity of B with respect to A, we can have, this is first form, and here we can have another form. So this relative velocity of B with respect to A, the respect to A, that we are considering at a as a first alphabet, and here as a first for this. Okay, so take down this, by taking vector difference, taking vector difference VAB is equal to vector VA minus vector VB this you can write equation 1. Then next line you can write vector BA. ग्राफिकल मध्ये असं दाखवणार आहे आपण स्मॉल लेटर्स ने, सो दॅट्स वाय यू कॅन राईट दिस. And whatever space available below this figure B, you can write VA greater than VB. VA greater than VB. This part we have completed. परत एकदा बघा, BA एवढा भाग जास्त आहे, right? So this is absolute velocity VA, this is absolute velocity VB. So this part, that is BA, just listen carefully, BA OA and OB. This segment minus this segment, and that will give BA. Right? समजलं का? रेवन्नाथ, ओंकार, समाधान, हॅलो,
हाँ सर.
एम आय ऑडिबल?
हाँ यस सर.
हा, समजलं का हे?
हाँ सर.
Okay. Up to this completed, Ajay?
Yes, sir.
Revannath, yes, okay. So, relative velocity of A with respect to B, that is VAB. We can take the vector difference, and from this figure, this BA म्हणजे हा एवढा भाग हा कसा मिळणार आहे आपल्याला? Just by this OA, that means this much length minus OB वजा OA मधून OB वजा केल्यानंतर तुम्हाला BA मिळणार. That we have written there. Okay. Next, you can write. Similarly, the relative velocity of B with respect to A. Relative velocity of B with respect to A in bracket, that is VBA may be written in the vector form as follows. In the vector form as follows. Then you can write by taking vector difference, next line, VBA, that means relative velocity of B with respect to A is equal to vector VB, this magnitude minus this. Okay, so write down vector AB. इथं कसं लिहायचं? A सुरुवातीला आणि B नंतर. आता ह्या केस मध्ये काय झालं लक्ष द्या. VB, this magnitude is less as compared to this. So this quantity is more as compared to this. So this we have written for the relative velocity of A with respect to B, relative velocity of B with respect to A. So we are going to write here AB, and by this much quantity it is less as compared to this VA. So how to write that? Vector AB, vector AB means relative velocity of B with respect to A. Here we are writing directly, and here we are what it indicates, relative velocity of B with respect to A is equal to OB minus OA minus OA, or just this is OB and this is OA. What is remaining? This AB is remaining. Okay. Take down this. Take all the content on the slide. Okay, up to this completed. So remember that VA and VB are absolute velocities. म्हणजे त्यांच्या स्वतःचे velocities. Body A and body B. That is absolute. एकमेकाच्या relative that we have determined. Okay. Next, write down relative velocities. So these things are important while drawing the velocity polygon velocity diagram and acceleration diagrams. Write down relative velocities of two bodies moving in two different directions. So numeric problems will be based on such conditions. Write down relative velocities of two bodies moving in two different directions. Moving in two different directions. In bracket you can write law of parallelogram of velocities or triangle law of velocities. that we are going to employ here. Draw these two diagrams, A and B. Then I will discuss. A is moving in this direction, body P is moving in this direction. What is this VB? This is absolute velocity of body P, VA, absolute velocity of body A. Draw this diagram and keep some space on the left hand side. Onkar, up to this completed?
Yes, sir.
Okay. Swapnil Kale, up to this completed. Have you drawn?
Yes, sir.
Okay. Okay. So already this we have discussed. So body B moving in a inclined direction. This is body B. It is moving in this direction. So if this one is the straight direction, it has some angle with respect to this straight direction. So A and B. So body A and B, this is direction for body B and this one is the direction for body A. Now this is figure which was given originally, and for this we are going to draw the vector diagram. Now how to draw this diagram? So already I asked you to draw initially. So we need to take any fixed point, and this one is the fixed point O. Accordingly, we need to draw vector OA. This is vector OA, which is parallel to this VA and with the same magnitude. So take any point, any fixed point O, and draw vector OA to represent this VA in magnitude and direction to some suitable scale. Some suitable scale. Now, for example, suppose this VA is given as 20 meter per second. This one is the absolute velocity. Now for drawing this diagram, as per our convenience, we are going to consider scale. Suppose this is 20 meter per second and this is 430 meter per second. These are the values for absolute velocity. So we can take scale that is 1 centimeter is equal to 10 meter per second. Don't write anything. So accordingly, for this 20 meter per second, we can have 2 centimeter distance, and for this 30 meter per second, we can have 3 centimeter distance. So this is about the scale based on the values given with respect to this VA and VB. So take any point, fixed point O, and draw vector OA to represent VA in the magnitude and direction by using the suitable scale. So this OA vector, this we need to draw initially. So I will write here first step, that is over. Now what is next step? With respect to this reference, this is reference for A and this is reference for B. So we can have the same starting point. So we have drawn this OA in the direction similar of this VA. Similarly, draw vector OB which represents VB in magnitude and direction with the same scale. जे स्केल आपण VA साठी घेतलं त्याच स्केलनी OB ड्रॉ करणं अपेक्षित आहे. So for one diagram there should not be two different scales. So OA we have drawn. Then how to draw this OB? Again parallel to this VB. Parallel to this VB. Okay. So VA is represented by OA. इथे arrow दाखवलाय. This arrow. Right? And same it is represented for this. Okay. So one vector we have drawn parallel to VA. One vector we have drawn parallel to VB. Initially हे दोन वेक्टर तुम्ही काढले. Right? Now this third vector, so this is end point for first vector and this is end point for the second vector. So starting point is OA and this one is the OB. Now then from B to A we need to draw one vector, and what will be the direction for this? So this one is the VA, this one is the VB, and this is VAB. Then this vector BA represents relative velocity of A with respect to B. Relative velocity of A with respect to B. And again the same vector, if you are going to read like this, vector AB, what it will indicate? Relative velocity of B with respect to A. That will be the case. So first of all, you can write this first point, second point, and the third point. Okay. Up to this completed? Ajay, up to this completed?
No, sir.
Please write. Okay. Next, we can have to determine VAB. How to determine VAB? Again, we are going to take the vector difference. So vector difference of VA and VB. So we have written vector VA minus vector VB. Vector VB. Now, as seen in the previous slide, so you should read once again this. Vector BA represent the relative velocity of A with respect to B. So this is A with respect to B. How to write that? Vector BA is equal to OA minus OB. OA minus OB. So this is VA. What is VA? VA is equal to this OA, this vector, and VB is equal to this OB. So from the diagram itself, we got this. Then write down this VAB is equal to vector difference of VA and VB is equal to this. Similar way, you can write relative velocity of B with respect to A. Take down this also. Up to this completed.
Yes, sir.
Next bit, you can write motion of a link. Motion of a link. Motion of a link. You can take this diagram. So A and B in your notebook. Then I will discuss one by one. Completed? Revannath completed?
Yes, sir. Yes.
Okay. Now, out of these two diagrams, so first you can see there are 2 points, point A and B, and what it indicates one rigid link. So this is rigid link AB. So suppose any component like this, just I am drawing one component here. This is point B and here point A. Let us consider this as a connecting rod. So connecting rod is nothing but one of the rigid link used in the IC engine. So 2 points, namely A and B, on this rigid link at each end. Okay. Then this point B is one of the extreme point on the link, and which will move relative to A. So this is A, and what is shown here, there is some angular velocity omega. That means this B is going to move relative to A, relative to A in clockwise direction. As indicated by arrow, this B is going to move relative to A in clockwise direction. Observing this A and B, there is no relative motion between A and B. म्हणजे हा B आहे इथं पॉइंट, हा A तिकडे जातोय किंवा हा B इकडे येतोय, राइट? और जस्ट B approaches towards A or A approaches towards B. That is not happening because this distance is remains same. B ह्या लिंकवर एक पर्टिक्युलर लोकेशनला आहे and A is at particular location. The distance between these two is not going to be changed. So this is once again a link. Here it is B and here it is A. For your information, I have drawn one more diagram. So this distance is not going to be changed. So B will move relative to A in clockwise direction, but this distance is not going to be changed. So relative motion of B with respect to A, in which manner it is going to take place? it is going to take place in perpendicular direction. So hence the relative motion of this B with respect to A must be in perpendicular direction. Now suppose I will show this is initial position. After some time, this will be the position, new position. Here I will write VBA as the distance between A and B is not changing. So I am showing that same magnitude by showing same length, whatever initially shown. So the relative motion of B with respect to A, it must be perpendicular to this AB, perpendicular to this AB, perpendicular to this AB dash, new position. So this VBA is perpendicular to this AB. Okay. So take down up to this. Please take down this write up. Last bit with respect to the fundamental concept. Then from the next slide we are going to start the examples. Up to this completed, Kiran.
Yes, sir.
So from this first one, this is important conclusion and it will be asked in EMCQ. So what is this note? Velocity of any point on a link with respect to another point on the same link is always perpendicular, to the line joining these points on the configuration or space diagram, So such type of question will be asked definitely with respect to the MCQs. So what will be another options? Always parallel. So this one is the correct one, always perpendicular. Again option will be A and B and fourth option will be none of these. So intentionally I have put this note on the slide so that you will understand what type of MCQs will be asked. So velocity of any point on a link with respect to another point on the same link is always perpendicular to the line joining these points on the configuration or the space diagram. So for example, just I will draw one 4-bar mechanism. So here A, B, C, and this one is D. This one is the fixed link. This is fixed link. So I will just show capital here A, C, and this one is D. Now this is first link, this is second link, this one is the third link, and this is fourth link. And what we are going to call it as a configuration or space diagram. अशी जर फिगर दिलेली असले पेपर मध्ये, क्वेश्चन पेपर मध्ये, so that is nothing but the space diagram or the configuration diagram. Right. Now this is point A, this is point B, and this is the line joining these 2 points. Joining these 2 points. And how to represent velocity of this point B. Velocity of this point B. So we are going to represent it like this. Just I will show in the diagram itself. So here we are going to show an arrow, and what is the angle here? 90 degree. And here we are going to write VBA. VBA. Velocity of B relative to A. And how it is indicated? So in this way we have indicated for this configuration. So for this configuration, how to indicate VBA? Just by drawing this arrow, and what will be the direction? It is in this direction. So please remember that velocity of any point on a link with respect to another point on the same link. This is another point A, this is point. For that we are going to represent the velocity. It is perpendicular to the link or the line joining these points. Then the relative velocity of B with respect to A, which is denoted by VBA, and it is represented by AB. This AB, it is represented by AB, which is perpendicular to this AB, perpendicular to line AB. ह्या फिगर मध्ये बघा, फिगर बी मध्ये AB काय रिप्रेझेंट करताय? रिलेटिव्ह व्हेलॉसिटी ऑफ B विथ रिस्पेक्ट टू A. फिगर A and this one is the figure B. आणि ही AB लाइन हे ह्या AB ला perpendicular. Small AB, a line indicated by small AB, is perpendicular to this line shown by the capital alphabet. Okay. Then now we are going to assume that omega, or just write omega is equal to angular velocity of link AB about A. Already we have shown this omega. So how to determine this VBA? We know V is equal to R omega. So VBA is equal to, what is radius? So that we are going to consider this AB. So that we are going to write here AB into omega. So VBA is equal to vector AB, this vector AB, VBA we have written, and what is value for that? Omega AB or AB omega. This is nothing but the radius. This is nothing but the radius. Okay. Similarly, we can consider another point, and it is denoted by C. Again, distance between this A and C is not going to be changed. It is fixed. Then relative velocity of this C with respect to this A, it will also perpendicular to this CA. So again, just I will take this part. Here it is A, here it is C. Again, we are going to show VCA. And how it is denoted? It is denoted with this AC in the same direction. So that's why in figure B, this AC indicating relative velocity of C with respect to A, and AB is nothing but relative velocity of B with respect to A. With respect to A. So similarly, you can write VCA is equal to AC. And how to determine? Again, R omega. And what is radius for this? That is AC into omega. How it is written here? VCA is equal to vector AC, and how to find out its magnitude? Omega AC. Same formulas we are going to use while solving the numericals with the graphical method. So initially we need to determine the linear velocity of input link. So for example, if such configuration is given, here this is A, this is B, C and D, and here it is shown omega, and timing I will take 20 radian per second. Then how to find this VBA or simply VB. So how to find VB? We need to take this 20 radian per second along with this distance. So that is required while solving the numericals of this velocity and acceleration. Okay. Now from equation this 1 and 2. So VCA, so dividing equation 2 by 1, VCA divided by VBA is equal to AC, is AC divided by AP. So what is value of AC? Omega into AC divided by omega into AB and is equal to just omega get cancelled. What is remaining? AC upon AP. AC upon AP. So from this equation 3, what we are observing? This point C on link AB and this small c on vector diagram divides this AB and this AB in the same ratio. So in other words, the point C on the vector AB, point C on the vector AB divides it in the same ratio as C divides the link AB, divides link AB. AB. So write down after this, up to this you have completed. Then from this part you can take. All the students, they should take this in their notebooks. Okay. Up to this completed? Ajay?
Yes, sir.
You can write velocity of rubbing, velocity of rubbing, and velocity of rubbing. Take down this diagram. Completed? Completed? Diagram completed?
Yes, sir.
Okay. Now just listen. So you know, in the mechanism there are different links. So once again I will draw one 4-bar mechanism. This is 4-bar mechanism. Okay. So this is A, this one is B, this is C, and this is D. Now here just I will show one dark circle, here as well, here as well, and here as well. So these indicates that there is turning pair, similar to this, So this OA is one link, this OB is another link, right? So they have joined with the help of one pin at this. So I will just write here, this is pin, and that is used to join these two links and or to form this turning pair. Now this link will rotate with some angular velocity. So just I will write here omega 1. It is in the clockwise direction, and suppose this is also rotating in the clockwise direction, I will write here omega 2. So if we are going to consider these two links separately, then this one is omega 2 and this is omega 1. And if you are going to consider another case where this is omega 1 and this one is omega 2. So just I will show omega 2, it is in anti-clockwise direction, and this one is omega 1 which is in the clockwise direction. So at the junction or at the joint there is rubbing between the two links. So for that we need to find out the rubbing velocity at this pin which is located at this O. So this is pin. So we need to find out rubbing velocity. पिन आहे अशी सेपरेट, अशी एक लिंक आहे आणि दुसरी लिंक अशी आहे. पिनच्या कॉन्टॅक्ट मध्ये हा लिंकचा सरफेस आहे आणि ह्याच पिनच्या कॉन्टॅक्ट मध्ये हा लिंकचा सरफेस आहे. तर त्या पॉइंटची और whatever rubbing velocity at that point, that we need to find out. So based on the directions of this omega 2, omega 1, omega 2 and omega 1. So how to determine this rubbing velocity? So already you have drawn the figure. So this we have seen links of mechanism are mostly connected by means of pin joint. Okay. How to define the rubbing velocity? The rubbing velocity is defined as algebraic sum between the angular velocities of the two links which are connected by pin joints multiplied by the radius of the pin. So we can determine this rubbing velocity just by writing omega 1 plus omega 2 into this radius. So rubbing velocity is defined as algebraic sum between angular velocities of two links. This OA is having omega 1 and OB is having angular velocity omega 2. One is in clockwise direction, other one is in anti-clockwise direction. So depending upon the sign convention, there is plus or minus sign, and remaining thing is nothing but the radius of this pin. So this one is the pin, and this pin will have some radius that we are going to write outside this circular bracket. So rubbing velocity is nothing but the algebraic sum between the angular velocities of two links which are connected with pin joints and multiply by the radius of the pin. Okay. So it depends upon the angular velocity of the link relative to the another. So this already we have seen. Now, so one more point I have mentioned here. What is that point? The velocity of rubbing is equal to omega 1 minus omega 2 into radius when links are moving in the same direction. This will be asked for MCQ. Definitely this will be asked for MCQ. And when links moving in opposite direction, omega 1 and omega 2 should be added and multiplied by the radius to get the velocity of rubbing, or simply the rubbing velocity. Now, for the configuration shown on the slide, how to get the rubbing velocity or the velocity of rubbing? Omega 1 plus omega 2 into radius, right? So एक पिन सेंटरला असे दोन हातामध्ये तुमच्या एक रॉड घ्या and you can just rub palm surface of right hand in clockwise direction and left hand in anti-clockwise direction. तर एका लिंकचं रबिंग प्लस दुसऱ्या लिंकचं रबिंग, त्या दोघांचं ऍडिशन होणं गरजेचं आहे, राईट? सो velocity of rubbing when links moving in opposite direction, wherein we need to sum up the angular velocities, and if links are moving in the same direction, at that time we are going to take the difference, that is omega 1 minus omega 2, किंवा whatever angular velocity which is having maximum quantity, through that we are going to subtract the minimum quantity, right? तर rubbing velocity म्हणजे काय की दोन लिंक्स एखाद्या पिन जॉइंटने जर कनेक्ट केले असतील आणि दोन्ही लिंक अपोजिट डायरेक्शन मध्ये रोटेट होत असतील, at that time rubbing for one link and rubbing for other link, that should be added, and if both the links are rotating in the same direction, then we are going to take the subtraction. So please take down these formulas. So this you should write velocity of rubbing first. Write down this content. Completed? Completed? Ajay, up to this completed?
Completed, sir.
Okay, so remaining part will take in, I will take in the next lecture.